living circle means living life cycle, meaning it will be described from the beginning of life till today, meaning from the oceanic environment to the terrestrial forest environment to today's moon living hypothesis list. Friends, do you know that our earth is actually carrying out the living circle process from the acidic era? What was the reputation of life on earth during the acidic age? The origin of life on earth stands as one of the great mysteries of science. Various answers have been proposed, all of which remain unverified. To find out if we are alone in the galaxy, we will need to better understand what geochemical conditions nurtured the first life forms, what water, chemistry and temperature cycles fostered the chemical reactions that allowed life to emerge on our planet. Because life arose in the largely unknown surface conditions of Earth's early history, answering these and other questions remains a challenge. Several seminal experiments in this topic have been conducted at the University of Chicago, including the Miller-Urey experiment that suggested how the building blocks of life could form in a primordial soup. Where did life on Earth begin? Two possibilities are in volcanically active hydrothermal environments on land and at sea. Some microorganisms thrive in the scalding, highly acidic hot springs environments like those found today in Iceland, Norway and Yellowstone National Park. The same goes for deep sea hydrothermal vents. These chimney-like vents form where the water comes into contact with magma on the ocean floor, resulting in streams of superheated plasma. The microorganisms that live near such palms have led some scientists to suggest them as the birthplace of Earth's first life form. Mineral-laden water emerging from a hydrothermal vent on the Niue underwater volcano in the Lau Basin, Southwest Pacific Ocean. The microorganisms that live near such plumes have led some scientists to suggest them as the birthplace of our first life form. Copyright U.S. Geological Survey. Schmidt Ocean Institute Virtual Bed. What was the first living thing on Earth? The origins of life on Earth curious. Prokaryotes were the earliest life form, simple creatures that laid on carbon compounds that were accumulating in Earth's early oceans. Slowly, other organisms evolved that used the sun's energy along with compounds such as sulfides to generate their own energy. 23 November 2018. When did complex life first appear on Earth? Studies suggest complex life was present on Earth. 2.33 billion studies suggest complex life was present on Earth 2.33 billion years ago. New estimate predates earliest fossil evidence by 800 million years. 6 March 217. Friends, don't think that complex life started on Earth around 2.33 billion years ago and the complexity of life has been destroyed. How many species of life exist in our world today? You may be surprised even after guessing. Estimated how many species are there in the world? 8.7 million species. There are more insects in them. Just think, friend, if so many insects were of great height like us, then perhaps the entire solar system would have to be made habitable for us. Well, today we need Moon and Mars because we humans are polluting the earth. This is what real love is. A woman with a man. There are mutual relation between the two. Possible the beginning of a new creation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginnings of a new creation. Possibly the beginning of a new creation. There are no neutron in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen alone fusion. When to do hydrogen alone fusion. There are no neutrons in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen atom fusion. When to do hydrogen alone fusion. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. Trees made flowers. Pollinate mutual relations. Fruits form seeds and roots form. Next is I about trees too. Next is I about trees too. Trees made flowers. Pollinate mutual relation. Fruits from seeds and roots from. Next is I about trees too. Next is I about trees too. This is what real love is. A woman with a man. There are mutual relation between the two, possibly the beginning of a new relation, possibly the beginning of a new creation. This is what real love is, a woman with a man. There are mutual relation between the two, possibly the beginning of a new creation, possibly the beginning of a new creation. Then, to understand the living circle, we will not be complete just by doing initial research and understanding today's situation. Living circle is also the process of nutrition, like what we eat, what we used to eat, what we drink, what we used to drink. By the way, there is a special description among our Hindus. By churning the ocean, nectar and poison were extracted for food. So, Lord Vishnu had prepared nectar as food for the gods and poison as food for mortal beings like us. I don't want to get into this argument to find the truth of our story, but I definitely want to elaborate on one truth. Actually, we depend on each other for food. The way we live, how to eat and digest, to get the right amounts of nutrients, people need to select from a range of food types: cereal, grains, fruits and vegetables, legumes, meat, poultry, fish and eggs, and milk and dairy products. A food pyramid outlines the suggested amount of these different types of food people should eat each a day. The digestive process starts in your mouth when you chew. Your salivary glands make saliva, a digestive juice which moistens food so it moves more easily through your esophagus into your stomach. Saliva also has an enzyme that begins to break down starches in your food esophagus. How do you digest and eat? Here's a tummy-friendly diet to aim for. Fill up on fiber to prevent constipation. Drink plenty of fluids to aid digestion. Cut down on fat for a healthy gut. Go easy on space to avoid tummy trouble. Beware gut symptom triggers. Choose the right drink to ease digestion probability. Why do we do it? Energy for activity, growth and all functions of the body such as breathing, digesting food and keeping warm. Materials for the growth and repair on the body. And for keeping the immune system healthy. Your digestive system, University of Michigan Health. https FM Health that organization. Conditions, treatment. Your digestive system is made up of a series of organs that allows your body to get the nutrients and energy it needs from the food we eat. What is actually necessary for the body, gas, liquid or solid through food, eat. National Geographic Society, https www.nationalgeographic.organization. Article Food. Food contains nutrients, substances necessary for the growth, repair and maintenance of body, tissues and the regulation of vital process. Grade 5 to 12 plus. What is my cell taking in through gas, liquid or solid nutrition? Diffusion and osmosis. Biology LibreText, https bio.libretext.organization. Biology tutorial, 18 June 2019. Description of diffusion and osmosis: a water solution that contains nutrients, wastes, gases, salts and other substances surround cells. How do cells take in gas molecules? 3. Simple diffusion across the cell plasma membrane. The structure of the lipid bilayer allows small uncharged substances such as oxygen and carbon dioxide and hydrophobic molecules such as lipids to pass through the cell membrane down their concentration gradient by simple diffusion. We are actually eating away at nature system. We are digesting the organisms which are carrying out photosynthesis through various means, meaning that light is our food, meaning hydrogen is our nutritional substances. Hydrogen reaction, not just fusion, not just water. This is atmosphere. Identity is also for life. Identity is also for life. This is atmosphere. Identity is also for life. Identity is also for life. Hydrogen reaction, not just fusion, not just water, not just fusion, not just water. Hydrogen reaction, not just fusion, not just water, not just fusion, not just water. This is solar system. Carbon component is not organic. Earth is but a weapon. There is organic and there is also biological. There is also organic and there is also biological. Earth is but a weapon. There is organic and there is also biological. There is carbonic. There is organic and there is also biological. This whole solar system. Carbon component is not organic. Carbon component is not organic. This whole solar system. Carbon component is not organic. Carbon component is not organic. Hydrogen reaction, not just fusion, not just water. This is atmosphere. Identity is also for life. Identity is also for life. This is Earth atmosphere. Identity is also for life. Identity is also for life. Hydrogen reaction, not just fusion, not just water, not just fusion, not just water. Hydrogen reaction, not just fusion, not just water, not just fusion, not just water. This entire solar system is a flow of hydrogen. There is no shortage of carbon here. Is the entire solar system subject to the carbon cycle? Dust in the interstellar medium ISM is a well-mixed distribution of carbonaceous and silicate grains that ultimately serve as a source for the solids in the solar nebula. According to this model, roughly 88% of the carbon and 100% of silicon, iron, magnesium and other metal oxides are in solids with a grain size distribution proportional to 1:3.5. Graphene grains range from 0.005 to 1 micron in radius, while the silicate size ranges from 0.025 to 0.25 micron. Once these solids become part of a giant molecular cloud, they can become coated in ices of water, CO2 and ammonia that can be processed by UV photons generated by classic cosmic rays. Processing produces more complex molecular ices as well as an organic coating on the grains. These materials are heated as they fall into the solar nebula. In order to gauge the degree of heating and the stability of processing of these grains in the hot inner solar nebula, we will compare the initial theoretically distribution described above with the matrices of carbonaceous, chondrinate, silicate matrix grains range from 5 microns down to the nanometer scale. Other components of primitive meteorites are much larger, mm to cm, while carbon is generally 10% by mass. The implies that virtually all 99% of the presolar silicate grains were at least melted, if not vaporized, in order to transform them into this much larger size distribution. If nearly all silicates were processed at temperatures sufficient to melt and fuse grains into larger size aggregates, then the accompanying carbonaceous material must have reached similar temperature and been processed through related reaction. The initial solid state chemical distribution contains 8 into 106 carbon atom, 88% of carbon in graphite grains. For every 1 into 106 silicon atom, not counting any carbon added as an organic coating on grain surfaces. In order to calculate the oxygen abundance within the grains, we take the Si plus Mg plus Ap cosmic abundance of 2974 into 106 atoms and assume that the initial valence state of Si is plus 4, Mg is plus 2 and Ap is half plus 2 and half plus 3. If all metals are saturated oxides, then the amount of oxygen in dust is 4.087 into 106 atoms. Again, not counting any oxygen in organic dust, mantles, if these were a closed chemical system, then all of the silicon, magnesium and iron would be reduced to the respective metal. Roughly half of the carbon would be converted to CO and half would remain as graphite. Since most metals in meteorites, matrix and oxidized and carbon is an insignificant fraction of their total mass, thermal processing must have occurred in an open system. The cosmic abundance of nebulae, oxygen is 18.8 into 106 for every 106 silicon atom. So oxygen is roughly twice as abundant as carbon and occurs primarily as CO, O, OH and H2O at high temperature. There is sufficient nebular oxygen to oxide all of the remaining carbon to CO and CO2 and all of the metals back to oxide if any were actually reduced in the first place and still leave 107 oxygen atom in water and other gas-phase oxide. Connolly et al. Have demonstrated that the addition of a small fraction of carbon as graphite or diamond to an experimental charge of olivine and pyroxene grains produces excellent Chandrula analog. In addition, during rapid experimental heating, the internal redox state of the melt does not immediately equilibrate with the gas mixture used to control the oxygen fugacity of the experiment. Instead, the micro environment inside the experimental charges is much more reducing than the gas and therefore produces metallic grain within the melt rather than just along the surface of the charge. This Chandrula analog closely resemble natural samples. In summary, the processing of the silicate grain population from its pre-solar size distribution into much larger planets, asteroids, calcium, aluminum, inclusions CALS, Chandrulas, and matrix implies that the associated carbonious materials were exposed to similar temperatures in a sufficient excess of oxygen to convert all carbon atoms into CO and CO2. While some molecular cloud carbonaceous dust did survive processing in the nebula, much in the same manner as did some pre-solar oxide grains. 8 such materials constitute only a small fraction of meteoritic carbon and are clarified, distinguished by elevated DH15N 13N 13C by 12C or other isotopic ratios are or noble gas patterns. Under such circumstances, why does carbon exist beyond trace amounts in the inner solar system at all? How is solar energy related to the carbon cycle? Solar power produces no emissions during generation itself, and life cycle assessment clearly demonstrate that it has a smaller carbon footprint from cradle to grave than fossil fuel. Do solar panels produce CO2? Solar panels emit around 50 grams of CO2 per kWh produced in its first few years of operation. By the third year of having solar panels, most solar panels become carbon neutral. Where is carbon in solar system? Just about everywhere. you look in the solar system, you find carbon from the searing atmosphere of Venus to the oily flesh of Titan to the hair of the dog that feed you. In fact, carbon is the fourth most common element in the solar system after hydrogen, helium and oxygen. 11 November 2019. Hydrogen reaction, not just fusion, not just water. This is atmosphere. Identity is also for life. Identity is also for life. This is atmosphere. Identity is also for life. Identity is also for life. Hydrogen reaction, not just fusion, not just water, not just fusion, not just water. Hydrogen reaction, not just fusion, not just water, not just fusion, not just water. This whole solar system, carbon component is not organic. Earth is but a weapon. There is organic and there is also biological. There is also organic and there is also biological. Earth is but a weapon. There is organic and there is also biological. There is carbonic. There is organic and there is also biological. This whole solar system, carbon component is not organic. Carbon component is not organic. This whole solar system, carbon component is not organic. Carbon component is not organic. Hydrogen reaction, not just fusion, not just water. This is atmosphere. Identity is also for life. Identity is also for life. This is atmosphere. Identity is also for life. Identity is also for life. Hydrogen reaction, not just fusion, not just water, not just fusion, not just water. Hydrogen reaction, not just fusion, not just water, not just fusion, not just water. Hydrogen. Hydrogen is a substance which is found everywhere in our entire solar system. Hydrogen is present in the largest quantity in the entire universe. Most of the hydrogen is held hostage by the stars. Their hydrogen has its own freedom. For example, 70% of our sun is only hydrogen. Hydrogen always continues its fusion in the sun. What is the characteristic of hydrogen? Hydrogen is an atomic numbered chemical element 1. Hydrogen is a colorless, odorless, non-metallic, tasteless, extremely flammable, diatomic gas with molecular formula H2 at standard temperature and pressure. 21 July 2020. What is hydrogen and its uses? Hydrogen has many actual and potential uses. Hydrogen is currently used in industrial processes as rocket fuel and in fuel cells for electricity generation and powering vehicles. Operators of several natural gas fired power plants are exploring the use of hydrogen to supplement to replace natural gas 23 June 2023. How is hydrogen used for life? Without hydrogen, we would not have the sun to give us heat and light. There would be no useful organic compound to form the building block of life, and that most essential substance for life's existence, water, would not exist. How is hydrogen useful to humans? The most important function of hydrogen in the human body is to keep you hydrated. Water is made up of hydrogen and oxygen and is absorbed by the cells of the body. Therefore, it is a crucial element which is used not in our body but also as a fuel in military, weapons, etc. 26 October 2017. How to make hydrogen? The two most common methods for producing hydrogen are steam, methane, reforming and electrolysis, splitting water with electricity. Researchers are exploring other hydrogen production methods or pathways. 23 June 2020. Is hydrogen used in everyday life? Hydrogen can be used to power vehicles, generate electricity, power industry, and heat our homes, our businesses. It could make a huge difference on our carbon emissions and will be critical to achieving net zero. 23 February 2023. What is the formula for hydrogen? H2. Hydrogen is a chemical element. It has symbol H and atomic number 1. It is the lightest element and at standard conditions is a gas of diatomic molecules with the formula H2. It is colorless, odorless, tasteless, non-toxic and highly combustible. This is what a real love is. A woman who is a man. There are mutual relation between the two. Possible the beginning of a new creation. Possibly the beginning of a new creation. This is what a real love is. A woman with a man. There are mutual relation between the two. Possibly the beginnings of a new creation. Possibly the beginning of a new creation. There are no neutron in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen alone fusion, when to do hydrogen alone fusion. There are no neutrons in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen atom fusion, when to do hydrogen alone fusion. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of new creation. Possibly the beginning of new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of new creation. Possibly the beginning of new creation. Trees made flowers, pollinate mutual relations. Fruit form seeds and roots form. Next is I about trees too. Next is I about trees too. Trees made flowers, pollinate mutual relations. Fruit from seeds and roots from. Next is I about trees too. Next is I about trees too. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new relation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. Which is the biggest truth? That is, hydrogen can react with itself and converts into helium. The most important thing is that hydrogen gets separated into helium and remains in the plasma. Still, fusion is a big secret in the constellation, like it happens in our sun. Do hydrogen and helium bond together? Certainly, one can mix hydrogen gas, which will be mostly H2 molecules, with helium gas, which will be made of individual He atoms. But they will not bond together because He is an inert gas. It doesn't react chemically with other atoms or molecules. What is the process of hydrogen bonding to become helium called nuclear fusion in our sun? In proton fusion, hydrogen atoms are fused together through several steps to eventually become a helium-4 atom. Initially, two hydrogen atoms collide, forming a single deuterium atom. A position and a deuterium is an isotope of hydrogen. Wikipedia, https en.wikipedia organization, wiki helium hydride ion. The helium hydride ion, hydridohelium 1 plus ion or helonium is a Cushion positively charged ion with chemical formula HeH plus. It consists of a helium atom bound to a hydrogen atom with one electron removed. It can also be viewed as protonated helium. It is the lightest heteronuclear ion and is believed to be the first compound formed in the universe after the Big Bang. The ion was first produced in a laboratory in 1925. It is stable in isolation but extremely reactive and cannot be prepared in bulk because it would react with any other molecule with which it came into contact. Noted as the strongest known acid, stronger than even fluorouronic acid. Its occurrence in the interstellar medium had been conjectured since the 1970s and it was finally detected in April 2019 using the airborne SOFIA telescope. Nuclear reaction. So, if gravity can't power the sun, how about processes inside an atom? We have two choices here. Chemical reaction. Reactions dealing with atomic bonds between atoms and electrons. Typically, energy per atom of around 10 electron volts. The amount of energy stored in the atomic levels of hydrogen and helium. Not enough energy to power the sun for very long, less than gravity. Nuclear reaction. Reactions between atomic nuclei. Typical energies are millions of times larger than for chemical reaction. Lots of energy available. So, time for a little nuclear physics. Woo-hoo inside the atom. Let's look at hydrogen and helium, 98% of the sun. At the center of the sun, the temperature is high enough and hydrogen and helium and just about everything else is ionized. The electrons are no longer bond attached to the atom. We just deal with bare nuclei. Let's do a few definitions to make life easier. First, define the atomic mass unit as being 1/12 of the mass of the carbon 12 atom. 1 AMU is equal to 1.660540 into 10 to 27 kg. Next, bring Einstein into the picture. Einstein realized that E is equal to mc2. Mass and energy are equivalent, related by the speed of light, c. So we can also talk about mass in terms of energy. 1 AMU is equal to 931.5 million electron volts, MEV. V, when 1 EV is equal to 1.6 into 10 to 19 joule. By the way, it is due to nuclear fusion in the sun that this living life is here. This is life here, the means to survive are here. This water and that ray, where will we find the right earth without it? Where will we find the right earth without it? This is life here, the means to survive are here. This water and that ray, where will find the right earth without it? Where will we find the right earth without it? Trees do photosynthesis, animals release carbon dioxide, trees release oxygen. Oxygen is the word of living, giving. Oxygen is the word of living, giving. Trees do photosynthesis. Animals release carbon dioxide. Trees release oxygen. Oxygen is the word of living, giving. Oxygen is the word of living, giving. This is life here, the means to survive are here. This water and that ray, where will we find the earth without it? Where will we find the right earth without it? This is life here, the means to survive are here. This water and that ray, where will we find the right earth without it? Where will we find the right earth without it? Life is of many species, lies also in increase. Life is life by eating, living, giving. This is the process of living. This is the process of living. Life is of many species. Life also increases. Life is life by eating, living, giving. This is the process of living. This is the process of living. This is life here, the means to survive are here. This water and that ray, where will we find the right earth without it? Where will we find the right earth without it? This is life here, the means to survive are here. This water and that ray, where will we find the right earth without it? Where will we find the right earth without it? It is said that this earth is the only place where life exists. There is no life preserver like earth anywhere in this entire solar system. Yes, but there is one truth for which there is no alternative, that is life. We live by eating life. You know, friends, every life in the world is living by killing and eating every life. What is population conservation and how is it created? Environmental protection is a global issue with a plethora of protective legislation enacted as transnational and national regulation and guidelines aimed at sustainable use of water, soil, air and biomass. These laws apply not only to the polluter but also to government, national institutions and individuals. Population, Species and Conservation Genetics (PMC), National Institutes of Health, Government. https www.ncbi.nlm.nih.government. Article PMC 7150084. Conservation genetics is concerned with population genetic variation, population viability and the future evolution of species. Conservation genetics, ecology and habitat management together provide the technical underpinning of conservation biology, a crisis-oriented science of biodiversity management. Still in its infancy, conservation genetics focuses on the characterization of variation in populations and species and on the management of innate levels of variation in evolutionarily significant units in nature and in their capture or managed analog. Conservation genetic methods are borrowed from evolutionary biology and molecular genetics and are under development. Although some genetic management principles flow directly from current evolutionary theory, several key scientific problems remain to be solved before we can effectively deal with the issues presented by the biodiversity crisis. Although single species ecological methods have dominated conservation management practice, it is clear that maintaining the future evolvability of species will require greater genetic intervention in the future. Conservation genetics is thus a cornerstone of biodiversity conservation. What is meant by environmental protection? Environmental protection, Wikipedia. April 2022. Environmental protection is the practice of protecting the natural environment by individuals, groups and government. Its objectives are to conserve national resources and the existing national environment, and where it is possible to repair damage and reverse trend. What is the origin of conservation biology? The term conservation biology and its conception as a new field originated with the convening of the first international conference on research in conservation biology held at the University of California, San Diego in La Jolla, California in 1978, led by American biologists Bruce A. Wilcox and Mikhail E. What is environmental protection? SI on environmental protection. Environmental protection is a practice that aims to protect the natural environment from the hands of individuals, organizations, and government. It is the need of the hour because the earth environment is deteriorating every day, and the reasons are human beings. 12 October 2020. This is life here, the means to survive are here. This water and that ray, where will we find the right earth without it? Where will we find the right earth without it? This is life here, the means to survive are here. This water and that ray, where will we find the right earth without it? Where will we find the right earth without it? Trees do photosynthesis, animals release carbon dioxide, trees release oxygen. Oxygen is the word of living, giving. Oxygen is the word of living, giving. Trees do photosynthesis, animals release carbon dioxide, trees release oxygen. Oxygen is the word of living, giving. Oxygen is the word of living, giving. This is life here, the means to survive are here. This water and that ray, where will we find the earth without it? Where will we find the right earth without it? This is life here, the means to survive are here. This water and that ray, where will we find the right earth without it? Where will we find the right earth without it? Life is of many species, lies also in a creed. Life is life by eating, living, being. This is the process of living. This is the process of living. Life is of many species. Life also increases. Life is life by eating, living, being. This is the process of living. This is the process of living. This is life here, the means to survive a real. This water and that ray, where will we find the right earth without it? Where will we find the right earth without it? This is life here, the means to survive a real. This water and that ray, where will we find the right earth without it? Where will we find the right earth without it? Life is a wonderful structure on our entire world. Guys, can you shed some light? Which life was the first to appear on this entire earth of ours? Early life on earth, animal origins, Smithsonian National Museum of Natural History, https naturalhistory.si.edu. Education, life science in the beginning. Today we take for granted that we live among diverse communities of animals that feed on each other. Our ecosystems are structured by feeding relationships like killer whales eating seals, which eat squid, which feed on krill. These and other animals require oxygen to extract energy from their food. But that's not how life on earth used to be. With an environment devoid of oxygen and high in methane for much of its history, earth would not have been a welcoming place for animals. The earliest life forms we know of were microscopic organisms, microbes, that left signals of their presence in rocks about 3.7 billion years old. The signals consisted of a type of carbon molecule that is produced by living things. Evidence of microbes was also preserved in the heart structure, stromatolites they made, which dates to 3.5 billion years ago. Stromatolites are created as sticky mats of microbes trap and bind sediments into layers. Minerals precipitate inside the layers, creating durable structures even as the microbes die off. Scientists study today's rare living stromatolite reefs to better understand Earth's earliest life form. What was the first life on Earth? The earliest life forms we know of were microscopic organisms, microbes that left signals of their presence in rocks about 3.7 billion years old. The signals consisted of a type of carbon molecule that is produced by living things. History of life, Wikipedia, https en Wikipedia organization, Wiki History of Life. The history of life on Earth traces the processes by which living and fossil organisms evolved from the earliest emergence of life to present day, Earth formed about 4.5 billion years ago, abbreviated as Ga for giganium, and evidence suggests that life emerged prior to 3.7 Ga. Although there is some evidence of life as early as 4.1 to 4.28 Ga, it remains controversial due to the possible non-biological formation of the purported fossils. How did life begin on Earth? We asked a NASA scientist. NASA.government. HTTPS www.nasa.government. General, how did life begin? 24 July 2023. Well, actually we don't know. But even trying to answer it is super fun because it takes us to like all these crazy, imaginative places and environment. Some people think it started in hydrothermal vents at the deepest, darkest, warmest parts of the ocean. Some people think it created in this little pond that materials collected and concentrated within. And other people think it may be formed in environments that were a combination of those things. Like maybe a big impactor came in from space and made a pond with a vent at the bottom of it. And part of how we research this is by looking at those environments, the wild places that could have existed on Earth, early Earth, that led to the formation of life. The chemistry that required for life to have originated, and then also thinking about what life is in the first place and what life requires. At NASA, we found the chemists and the geologists and the astronomers and the planetary scientists that you need to bring to the same table to answer those questions in detail. We do that through NASA's astrobiological program, and we incorporate thinking on how life originated or could originate elsewhere into our missions and our planning to look for life on planets beyond Earth, whether that's on Mars or in the ocean world of our outer solar system, or with a big space telescope that could look for signs of life on planets around other stars. So, how did life begin on Earth? We don't know, but we are working on it because it's important both to the story of here, our history of life on our home planet. It's important also for our search for life beyond Earth and answering the other questions of, are we alone? This is what real love is. A woman with a man There are mutual relation between the two. Possible the beginning of a new creation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginnings of a new creation. Possibly the beginning of a new creation. There are no neutron in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen alone fusion. When to do hydrogen alone fusion. There are no neutrons in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen atom fusion. When to do hydrogen alone fusion. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. Trees made the flowers. Pollinate mutual relations. Fruit from seeds and roots from. Next is I about trees too. Next is I about trees too. Trees made the flowers. Pollinate mutual relation. Fruit from seeds and roots from. Next is I about trees too. Next is I about trees too. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new relation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. Maybe we don't know yet how life was created. But friends, can you throw some light on how we humans came into existence on this earth? Human evolution, the story of human origin, evolution news, https www.evolutionnews.organization. The economic images of apes evolving into human are more imagination than reality. Science Uprising Episode 8, Human Evolution, The Monkey Bias. Watch now. Biotic. Homo sapiens, the first modern humans, evolved from their early hominid predecessors between 2 million and 3 million years ago. They developed a capacity for language about 50,000 years ago. The first modern humans began moving outside of Africa starting about 70,000 to 1 million years ago. How did humans evolve? History Channel. https www.history.com. Topic: Prehistory. 5 March 2020. The story of human origins is complicated since our ancestors swapped genes and probably skills. On the biggest steps in early human evolution, scientists are in agreement. The first human ancestors appeared between 5 million and 7 million years ago, probably when some ape-like creatures in Africa began to walk habitually on 2 legs. They were fucking crude stone tools by 2.5 million years ago. Then some of them spread from Africa into Asia and Europe after 2 million years ago. With somewhat less certainly, most scientists think that people who look like us, anatomically modern Homo sapiens, evolved by at least 1,030,000 years ago from ancestors who had remained in Africa. Their brain had reached today's size. They too moved out of Africa and eventually replaced non-modern human species, notably the Neanderthals in Europe and parts of Asia, and Homo creatures typified by Java man and Peking man fossils in the Far East. But agreement breaks down completely on the question of when, where and how these anatomically modern humans began to manifest creative and symbiotic thinking. That is, when did they become fully human in behavior as well as body? When and where was human culture born? How did humans start on the earth? Human evolution is the lengthy process of change by which people originated from ape-like ancestors. Scientific evidence shows that the physical and behavioral traits shared by all people originated from ape-like ancestors and evolved over a period of approximately 6 million years. 3 January 2024. How did the human beings come into existence? Anatomically, modern humans emerged around 3 million years ago in Africa, evolving from Homo heidelbergensis or a similar species migrating out of Africa. They gradually replaced and interbred with local populations of archaic humans. For most of their history, humans were nomadic hunter-gatherers. Anyway, in this entire biological world, we humans community is the best. Any doubt? Face the world. We live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. We humans, the surface in the world. We created aircraft in the transportation. Sky our rocket news. Sky our rocket news. We humans, the surface in the world. We created aircraft in the transportation. Sky our rocket news. Sky our rocket news. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. Two satellites, diagnosis of even every moment the asteroid review. Dinosaur era crisis should not return again. Dinosaur era crisis should not return again. To the satellite diagnosis of every moment asteroid review. Dinosaur era crisis should not return again. Dinosaur era crisis should not return again. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. By the way, we also call our moon a satellite. And we humans have also created satellites. For what programs do we humans make satellites? Write some uses of human-made satellites. Byju's. https byju's.com. Question answer. Write some uses. 3 July 2022. Following are some uses of human-made satellites: navigation, weather prediction, communication, safety, and observation of space. What are human-made satellites? Give 2 examples. Byju's. https byju's.com. Question answer. What are human-made satellite is an artificial body. It is designed by scientists to gather information about the universe or for communication. From Wikipedia, the free encyclopedia, this article is about human-made satellites. A satellite or artificial satellite is an object, typically a spacecraft, placed into orbit around a celestial body. Satellites have a variety of uses, including communication, relay, weather forecasting, navigation, GPS, broadcasting, scientific research, and Earth observation. Additional military uses are reconnaissance, early warning, signals, intelligence, and potentially weapon delivery. Other satellites include the final rocket stages that place satellites in orbit and formerly useful satellites that later become defunct. How do satellites help humans? Quora, https www.quora.com. How do satellites help humans? How do satellites help humans? Is the Rosetta mission worthwhile? Do space experts think it is a good use of resources? How will landing a satellite on a comet help the human race? Originally answered, is the Rosetta mission worthwhile? Do space experts think it's a good use of resources? Yes. Rosetta is an important and valuable mission. If successful, it could be one of the most important missions ever. Comets are extremely old and primitive. They contain evidence of the beginning of the solar system and the cloud that preceded it. While planets and moons have evolved, comets are essentially frozen in time until they approach the sun. It is believed that Earth obtained its oceans from comets, and some also suggest that organic compounds that led to the formation of life may have been provided in those some comets. Recent evidence suggests some of these comets were older than our solar system. Human spaceflight. The Cold War between the United States and former Soviet Union gave birth to the space race and an unprecedented program of scientific exploration. The Soviets sent the first person into space on April 12, 1961. In response, President John F. Kennedy challenged our nation to achieving the goal before this decade is out of landing a man on the moon and returning him safely to Earth. It took 8 years and 3 NASA programs: Mercury, Gemini, and Apollo. But the United States got to the moon. the world. We live here in the world. We humans are the best among all the living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. We humans, the surface in the world. We created aircraft in the transportation. Sky our rocket news. Sky our rocket news. We humans, the surface in the world. We created aircraft in the transportation. Sky our rocket news. Sky our rocket news. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. Choose satellite, diagnosis we are. Even every moment the asteroid review. Dinosaur era crisis should not return again. Dinosaur era crisis should not return again. To the satellite, diagnosis we are. Every moment asteroid review. Dinosaur era crisis should not return again. Dinosaur era crisis should not return again. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. This world, we live here in the world. We humans are the best among all living beings. Even the stars rotate, only humans explain. Even the stars rotate, only humans explain. Well, we humans are the best. Some truth about this has been mentioned in our Hindu scriptures. After experiencing Satya Yuga, Treta Yuga, Dwapar Yuga and Kali Yuga. And by the way, in the creation of Kali Yuga, King Janmejaya had started by performing the best Mahayagya. By the way, we ourselves are members of this Kali Yuga. What is the truth that Treta, Dwapar and Kali Yuga have been made the incarnation of Lord Vishnu in our Hindu scripture, who was Narasimha incarnation in Satya Yuga, Ram in Treta Yuga, Krishna in Dwapar era. Nimai is the loving incarnation of Kali Yuga. But the calculation of this era has happened like this in our entire human life. Stone Age, Iron Age, Copper Age, etc. Well, what was the first Stone Age tectonic event in our human civilization? Stone Age. Wikipedia, HTTPS, Yen, Wikipedia organization, Wiki, Stone Age. The Stone Age was a broad prehistoric period during which stone was widely used to make stone tools with an edge, a point or a percussion surface. Missing tectonic, snow results with tectonic. Key components of civilization, National Geographic Society, https www.nationalgeographic.organization, article Key Co. The Indus Valley civilization was a Bronze Age civilization in what is now Pakistan, India and Afghanistan. Civilization describes a complex way of life that came about as people began to develop networks of urban settlement. The earliest civilization's development between 4000 and 3000 BCE, when the rise of agriculture and trade allowed people to have surplus food and economic stability. Many people no longer had to practice farming, allowed a diverse array of professions. And interest to flourish in a relatively confined area. Civilization first appeared in Mesopotamia, what is now Iraq, and later in Egypt. Civilizations thrived in the Indus Valley by about 2500 BCE, in China by about 15,000 BCE, and in Central America, what is now Mexico, by about 12,000 BCE. Civilization ultimately developed on every continent except Antarctica. Characteristics of civilization. All civilizations have certain characteristics. These include large population centers, monumental architecture and unique art styles, shared communication, strategic system for administrating territories, a complex division of labor and the division of people into social and economic classes. The development of urban settlements, cities, is the primary characteristics of a civilization. The other attributes that define civilization are built around urbanization, urban areas. Large population centers or urban areas allow civilizations to develop, although people who live outside these urban centers are still part of that region's civilization. Rural residents of civilization may include farmers, fishers and traders who regularly sell their goods and services to urban residents. The huge urban center of Teotihuacan in modern day Mexico. For example, had as many as 2 million residents between 300 and 600 CE. The development of the Teotihuacano civilization was made possible in part by the rich agricultural land surrounding the city. As land was cultivated, fewer farmers could supply more food staples such as corn and beans. To more people. Trade also played a part in Teotihuacan's urban development. Much of the wealth and power of Teotihuacan was due to excavating and trading the rich deposits of obsidian around the city. Obsidian is a hard volcanic rock that was highly valued as a cutting tool. Teotihuacano merchants traded, exported obsidian to surrounding cultures in exchange for goods and services imported to Teotihuacano settlement. This is what a real love is. A woman with a man. There are mutual relation between the two. Possible the beginning of a new creation. Possibly the beginning of a new creation. This is what a real love is. A woman with a man. There are mutual relation between the two. Possibly the beginnings of a new creation. Possibly the beginning of a new creation. There are no neutron in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen alone fusion. When to do hydrogen alone fusion. There are no neutrons in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen atom fusion. When to do hydrogen alone fusion. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. Trees made flowers. Pollinate mutual relations. Fruit form seeds and roots form. Next is I about trees too. Next is I about trees too. Trees made flowers. Pollinate mutual relation. Fruit from seeds and roots from. Next is I about trees too. Next is I about trees too. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new relation, possibly the beginning of a new creation. This is what real love is, a woman with a man. There are mutual relation between the two, possibly the beginning of a new creation, possibly the beginning of a new creation. Stone Age, Copper Age, Iron Age, whatever the civilization may be, but the most famous is today's space search era. Maybe you don't understand, friend. I am describing the story of human misdeeds in the present world. This new human world of ours has entered a new era. In today's great civilization, which countries have played a role in the path of space travel, space exploration is the use of astronomy and space technology to explore outer space. While the exploration of space is currently carried out mainly by astronomers with telescopes, its physical exploration is conducted both by uncrewed robotic space probes and human space flight. Space exploration, like its classical form, astronomy is one of the main source for space science. While the observation of objects in space known as astronomy predates reliable recorded history, it was the development of large and relatively efficient rockets during the mid 20th century that allowed physical space exploration to become a reality. Common rationales for exploring space include advancing scientific research, national prestige, uniting different nations, ensuring the future survival of humanity, and developing military and strategy advantages against other countries. The early era of space exploration was driven by a space race between the Soviet Union and the United States. A driving force of the start of space exploration was during the Cold War. After the ability to create nuclear weapons, the narrative of defense, offense, left, land, and the power to control the air became the focus. Both the Soviets and the US were fighting to prove their superiority in technology through exploring the unknown. Space. In fact, the reason NASA was made was due to the response of Sputnik 1. The launch of the first human-made object to orbit Earth, the Soviet Union's Sputnik 1, on 4 October 1957, and the first moon landing by the American Apollo 11 mission on 20 July 1969 are often taken as landmarks for this initial period. The Soviet space program achieved many of the first milestones, including the first living being in orbit in 1957, the first human spaceflight, Yuri Gagarin aboard Vostok 1 in 1961, the first spacewalk by Alexei Leonov on 18 March 1965, the first automatic landing on another celestial body in 1966, and the launch of the first space station, Salyut 1, in 1971. After the first 20 years of exploration, focus shifted from one-off flights to renewable hardware, such as the Space Shuttle program, and from competition to cooperation as with the International Space Station ISS. With the substational completion of the ISS following STS-133 in March 2011, plans for space exploration by the US remain in flux. Constellation, a Bush administration program for a return to the moon by 2020 was judged inadequately funded and unrealistic by an expert review panel reporting in 2009. The Obama administration proposed a revision of Constellation in 2010 to focus on the development of the capability for crewed missions beyond low Earth orbit (LEO), envisioning extending the operation of the ISS beyond 2020, transferring the development of launch vehicles for human crews from NASA to the private sector, and developing technology to enable missions to beyond LEO, such as Earth Moon L1, the Moon Earth Sun L2, near Earth asteroids, and Phobos or Mars orbit. In the 2000s, China initiates a successful crewed spaceflight program, while India launched Chandrayaan-1. While the European Union and Japan have also planned future crewed space missions, China, Russia, and Japan have advocated crewed missions to the moon during the 21st century, while the European Union has advocated crewed missions to both the moon and Mars during the 20th and 21st century. Well, our country India is not behind, but one thing is there. We are traveling through planets and satellites so that we can see what are they are, so that someday we can settle human there. That's why water is so important. Life without water impossible after all. To live every moment. Water is the expert. To live every moment. Water is the expert. Life without water impossible after all. To live every moment. Water is the expert. To live every moment. Water is the expert. Hydrogen, oxygen make to water, water and ice too. Even in the clouds of smoke, water and ice too. Even in the clouds of smoke, water. Hydrogen, oxygen mix to water and ice too. Even in the clouds of smoke, water and ice too. Even in the clouds of smoke, water. Life without water impossible after all. To live every moment, water is the expert. To live every moment, water is the expert. Life without water impossible after all. To live every moment, water is the expert. To live every moment, water is the expert. There 70% is water. Gas, dust and dirt remain. This life is the identity of the earth. Gas, dust and dirt remaining. This life is the identity of the earth. There 70% is of water. Gas, dust and dirt remaining. This life is the identity of the earth. Gas, dust and dirt remaining. This life is the identity of the earth. Life without water impossible after all. To live every moment, water is the expert. To live every moment, water is the expert. Life without water impossible after all. To live every moment, water is the expert. To live every moment, water is the expert. Gas, dust, soil, this life is due to rays and water. Water is the real truth of this world. It is said that without water, life on earth is worthless. What is the deep relationship between water and life on earth? Storyline. NGSS connection for teachers. Concept, boundaries for scientists, resources. Have you noticed that everything alive needs water? Your pets, trees and your family too. So why do you think that is? It's true that our bodies and other living things are made from all sorts of different things, but water makes up a lot of it. Also, when you look at a globe of earth, there really is a lot of water. Scientists have found that all living things need water. So, if we would like to try to find living things from some other planet, then maybe we should look for places that also have water. Grades 3 to 5 or adults, emerging learners. Storyline, NGSS connections for teachers, concepts, boundaries for scientists, resources. All living things on earth need water. Everything from pupil, plants, animals, and even mushrooms and things too small to see need water to survive. Even things like catchy in a desert need some water to live. Water seems to be very important for life. Have you ever looked at a globe? There is a lot of water. Since all living things that we know of need water, and many of us want to know if there could be other living things out there beyond Earth, then one thing we can do is investigate places with water beyond Earth. Mars had rivers and lakes of water a long time ago, and there could still be some water deep underground there today. Also, there are some moons around other planets that have lots of water. We need to continue to investigate these places and more, because if there is water, then there might be life too. Grade 6 to 8 or adult building learner, storyline, NGSS, connections for teachers, concept boundaries for scientists, resources. One attribute that is common to all living things that we know of is the need for water to survive. Even organisms that live in very dry places need water to live. Why? Why is water so important to living things? One reason that water is so important is because it's a liquid. This means that it can move around the materials that are needed for chemical reactions. These reactions include the ability for cells to get energy in and to move waste out. Water is made up of two atoms of hydrogen and one atom of oxygen that make a molecule. But water is a certain type of molecule called a polar molecule. Polar molecules have one side of the molecule that's a bit more positively charged and the other side a little more negatively charged. This allows water to more easily break apart or dissolve other molecules. That's why you can dissolve salt in water. There are actually a lot of other liquids that can do this, but water has other advantages as well. Water is very plentiful. About 70% of the surface of Earth is covered by water. From our oceans and our lakes to our rivers and streams, it turns out that water is also plentiful in the solar system. Comets have a lot of water within them. There is ample evidence that liquid water existed on ancient Mars in great quantities, and many moons have water under their surfaces. Water is super important for life as we know it. There might be other forms of life out there that don't rely on water the way we do. But looking for alien life in places with lots of water is one good way to start searching for possible extraterrestrial life. Storyline, NGSS, connections for teachers, concept boundaries for scientists, resources. All life on this planet needs water to survive. Some life can live with very little water in extremely dry places, but they still need water. As we strive to find life behind Earth, it is important to consider what life on Earth tells us about where to look. Why is water so important for life? Water supports cell functions. All organisms are made of cells, from microbes to the largest animals. All of life functions are completed within cells. Life needs chemical reactions to take place in order to gain energy, grow, and get rid of waste. Water is a liquid which allows the chemistry of life to take place. It is also a polar molecule which allows most other molecules to be dissolved. Because of this, we call water a solvent. Having such a good solvent as water is critical for the function of life. But there are also some other reasons why water is so important. Water is plentiful. Hydrogen is the most plentiful element in the universe, and oxygen the most plentiful in Earth's crust. On Earth, about 70% of the surface is covered by water, but there's also lots of water in other places in our solar system. For instance, we have found many lines of evidence that lots of water existed on the surface of Mars during its early time. And Mars currently has a lot of frozen water under its surface. Comets contain mostly water ice. There are lots of moons in our solar system that are made of a lot of water ice. And there are even some moons with liquid water oceans. Under their icy crust, like Europa and Enceladus, water still has other advantages as a solvent for life. For instance, water stays in the liquid phase over a large range of temperatures compared to some other solvents that allow more places to have the potential for liquid water. It also has a high heat capacity. This means that water offers some protection to organisms from quick or drastic temperature changes. Water also has an interesting property with regard to the density of ice. For many molecules, the solid has a higher density than the liquid. So, For most molecules, the solid would sink in the liquid. But this is not the case with water. For water, ice is actually less dense than liquid water. This is why ice floats. If this didn't happen, then all of the organisms that live in the bottoms of lakes in the winter time would be completely frozen. But even worse, during time in our planet history when the world has become very cold, causing what we call snowball earth. If frozen water sank, then all of our ocean life would have become frozen and maybe died. If we want to understand how life works, then it's really important to understand the chemistry of water, and astrobiologists who are wondering if we are alone in the universe need to be aware of the potential for water to be important for other kinds of life as well. Right now, we are investigating worlds like Enceladus and Europa, Mars and other solar system bodies that know signs of water. Also beyond our solar system, we are looking for exoplanets that have the potential for liquid water at their surfaces, since they might be important places for us to look for possible extraterrestrial life. Storyline extension: water is so cool. The range of temperature at which water stays liquid is rather large compared to most other common solvents. For instance, at sea level, methane freezes at -182 Celsius and boils at -162 C, a range of 21 C, and ammonia freezes at -78 degrees C and boils at -34 C, a range of 34 C. Meanwhile, water freezes at 0 C and boils at 100 C, a range of 100 C. This means that the range of temperatures where water is liquid is more than twice that of ammonia and almost 5 times more than that of methane. Water has a high surface tension. This means that the molecules at the surface of a body of water are attracted to each other and hold each other together. You can see this yourself by filling a glass with water to the very tippy top and then seeing how many more drops of water you can get into it. You will be surprised to find that you can actually get a good bit more water into the glass. The high surface tension of water is also why some insects like water striders and able to move around on top of water without sinking into it. It also is related to something called capillary action, which is used by many plants to draw water up from the ground against gravity. It's actually really rare for a solvent to be more dense as a liquid than as a solid. We know of other elements and molecules that are more dense as liquid, but it's far more common for the solid form of a substance to be more dense. Note, this is fairly advanced. Oxygen is a member of the group of elements known as the oxygen family, also sometimes called the chalcogens. These are the elements in the periodic table that are in group 16, the vertical column starting with oxygen and going down. They include oxygen O, sulfur S, selenium Se, tellurium Te, and polonium Po. All of these elements can form bonds with two hydrogen atoms. However, none of the other chalcogens come close to oxygen in its large range of temperatures where it is a liquid. This is because oxygen is much more electronegative, much greedier for electrons, and makes a far more polar molecule than the others. This greater polarity leads to stronger hydrogen bonding and the greater range of temperature for liquid water. Life without water impossible after all. To life every moment. Water is the expert. To life every moment. Water is the expert. Life without water impossible after all. To life every moment. Water is the expert. To life every moment. Water is the expert. Hydrogen, oxygen mixed to water, water and ice too. Even in the clouds of smoke, water and ice too. Even in the clouds of smoke, water, hydrogen, oxygen mixed to water and ice too. Even in the clouds of smoke, water and ice too. Even in the clouds of smoke, water. Life without water impossible after all. To life every moment. Water is the expert. To life every moment. Water is the expert. Life without water impossible after all. To life every moment. Water is the expert. To life every moment. Water is the expert. Say 70% is water. Gas, dust and dirt remain. This life is the identity of the earth. Gas, dust and dirt remaining. This life is the identity of the earth. Say 70% is of water. Gas, dust and dirt remaining. This life is the identity of the earth. gas dust and dust remaining. This life is the identity of the earth. Life without water impossible after all. To life every moment, water is the expert. To life every moment, water is the expert. Life without water impossible after all. To life every moment, water is the expert. To life every moment, water is the expert. Water, H2O. Friends, could this living circle ever be possible without water? It is said that the first beginning of the took place in the Earth's ocean was the world's first life, the isolated blue algae of the sea. Wikipedia, HTTPS, in Wikipedia.organization, wiki. Cyanobacteria. Cyanobacteria, is also called cyanobacteria or cyanophyta, are a phylum of gram-negative bacteria that obtain energy via photosynthesis. The name cyanobacteria refers to their color from ancient Greek guanus, blue, which similarly forms the basis of cyanobacteria's common name. Blue-green algae, although they are not usually scientifically classified as algae, appear to have originated in a fresh water or terrestrial environment. Cyanobacteria produce a range of toxins known as cyanotoxins that can cause harmful health effects in humans and animals. Cytochromatia, the proposed name of the paraphyletic and most basal group, is the ancestor of both the non-photosynthesis group, malign bacteria, and the photosynthetic cyanobacteria, also called oxyphotobacteria. Cyanobacteria use photosynthetic pigments such as carotenoid, phycobilins, and various forms of chlorophyll, which absorb energy from light. Unlike heterotrophic prokaryotes, cyanobacteria have internal membranes. These are flattened sacs called thylakoids, where photosynthesis is performed. Phototrophic eukaryotes such as green plants perform photosynthesis in plastids that are thought to have their ancestry in cyanobacteria, acquired long ago via a process called endosymbiosis. This endosymbiotic cyanobacteria in eukaryotes then evolved and differentiated into specialized organelles such as chloroplast, chromoplast, etioplast, and leucoplast, collectivity known as plastids. Cyanobacteria are the first organisms known to have produced oxygen and have been argued to be the most numerous taxon to have ever existed on Earth. By producing and releasing oxygen as a byproduct of photosynthesis, cyanobacteria are thought to have converted the early oxygen pore reducing atmosphere into an oxidizing one, causing the great oxidation event and the rusting of the earth, which dramatically changed the composition of life forms on earth. The cyanobacteria, Sneha and cyanoothes are important model organisms with potential applications in biotechnology for bioethanol production, food coloring as a source of human and animal food, dietary supplements and raw material. Was blue-green algae the first life on Earth? The origins of life on Earth curious, but let's start with what we know about some of the very first living things on Earth. Cyanobacteria, also known as blue-green algae, started out on Earth quite a while ago. Possible fossil examples have been found in rocks that are around 3,500 million years old in Western Australia, 23 November 2018. This is what real love is. A woman who is a man. There are mutual relation between the two. Possible the beginning of a new creation. Possibly the beginning of a new creation. This is what real love is. A woman who is a man. There are mutual relation between the two. Possibly the beginnings of a new creation. Possibly the beginning of a new creation. There are no neutron in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen alone fusion. When to do hydrogen alone fusion. There are no neutrons in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen atom fusion. When to do hydrogen alone fusion. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of new creation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. Trees made flowers, pollinate mutual relations. Fruit from seeds and roots form. Next is I about trees too. Next is I about trees too. Trees made flowers, pollinate mutual relation. Fruit from seeds and roots from. Next is I about trees too. Next is I about trees too. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new relation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. There are many estimates of the origin of water in the earth. Our scientific experience says that in the beginning the earth must have been composed of acidic and ice many times. So later there would have been intense volcanic activity, the result of which may have been this oceanic creation. How would water have started on earth? Water may also have come from volcanism. Water vapor originating in volcanic eruptions, condensing and forming rain. A sizable quantity of water would have been in the material which formed the earth. Water molecules would have escaped Earth's gravity more easily when it was less massive during its formation. Scientific American, HTTPS www scientificamerican.com. Article How D 6 October 290. About 70% of the surface of our planet Earth is covered in water. We are nestled in our solar system at just the right distance from the sun for the liquid water to exist any further, and that water would be frozen in ice. Any closer and temperatures would be too hot and we would be at risk for a runaway greenhouse effect similar to what's happening on the scorching surface of Venus. Our not too cold, not too hot position in the so-called Goldilocks zone is a pretty good thing because of course water is necessary for life. But how did that water get here? Water is a defining characteristic of our planet and it plays such an important part of our daily life. Understanding how water arrived on earth is a key part of understanding how and when life evolved here as well. But we don't even know how it, where it come from. Scientists are still actively researching how our planet got to be so wet in the first place. The early Earth. Our current picture of planet formation starts with a photoplanetary disk. That's a large disk of gas and dust swirling around our newly formed sun. As the grains of dust and ice in the disk interact with themselves, those grains begin to form bigger and bigger clumps. Eventually, those clumps form what we call planetesimals, the building blocks of rocky and giant planets. But in the early period of our solar system formation, that disk was much hotter at the position where our Earth sits now. So, even though there were most likely water molecules present in the mass of debris that made up the disk, it was too hot for water to condense into a liquid, causing it to evaporate instead. What's more, the early Earth did not yet have an atmosphere, making it easier for any liquid water droplets to be blown off into space. This leaves us with a bit of a puzzle. If the Earth could not have formed from the disk with its oceans already intact, how did they get here? How did water first appear on Earth? Origin of water on Earth, Wikipedia. Multiple geochemical studies have concluded that asteroids are most likely the primary source of Earth water. Carbonaceous chondrites, which are a subclass of the oldest meteorites in the solar system, have isotopic levels much similar to ocean water. Carnegie Science, HTTPS, carnegiescience.edu. How did Earth get its water? 12 April 2023, Washington, D.C. Our planet's water could have originated from interactions between the hydrogen-rich atmosphere and magma oceans of the planetary embryos that comprised Earth's formative years. According to new work from Carnegie Sciences, Annette Shah and UCLA Oculus Edward Young and Hilke soliciting their findings, which could explain the origins of Earth's signature features, are published in Nature. For decades, what researchers knew about planet formation was based primarily on our own solar system. Although there are some active debates about the formation of gas giants like Jupiter and Saturn, it is widely agreed upon that Earth and the other rocky planets accreted from the disk of dust and gas that surrounded our sun in its youth. As increasingly larger objects crashed into each other, the baby planetary cements that eventually formed Earth grew both larger and hotter, melting into a vast magma ocean due to the heat of collisions and radioactive elements. Over time, as the planet cooled, this tenacious material sank inwards, separating Earth into three distinct layers: the metallic core and the rocky silicate mantle and crust. However, the explosion of exoplanet research over the past decade informed a new approach to modeling the Earth's embryonic state. Exoplanet discoveries have given us a much greater appreciation of how common it is for just formed planets to be surrounded by atmospheres that are rich in molecular hydrogen H2 during their first several million years of growth. Shahir explained, eventually these hydrogen envelopes dissipate, but they leave their fingerprint on the young planet's composition. Using this information, the researchers developed new models for Earth formation and evolution to see if our home planet's distinct chemical traits could be replicated. Using a newly developed model, the Carnegie and UCLA researchers were able to demonstrate that early in Earth's existence, interaction between the magma ocean and a molecular hydrogen proto-atmosphere could have given rise to some of Earth's signature features, such as its abundance of water and its overall oxidized state. The researchers used mathematical modeling to explore the exchange of materials between molecular hydrogen atmospheres and magma oceans by looking at 25 different compounds and 18 different types of reactions. Complex enough to yield valuable data about Earth's possible formative history, but simple enough to interrupt it fully. Interaction between the magma ocean and the atmosphere in their simulated baby Earth resulted in the movement of large masses of hydrogen into the metallic core, the oxidation of the mantle, and the production of large quantities of water. After all, it is the creative chain of life algae in the ocean and trees in the terrestrial department that process this water. Trees have speciality, control the atmosphere. This series of trees of life. The sun seeds rays take advantage of it, the solar system. Life but alone on the earth. Life but alone on the earth. Trees have speciality, control the atmosphere. This series of trees of life. The sun is set, seeds rays take advantage of it, the solar system. Life but alone on the earth. Life but alone on the earth. Isolated in the ocean, there is the oxygen that is to the world of the plant. It's called the algae. Life is like a beehive. This is the world of the breeze. This is the world of the breeze. Isolated in the ocean, there is oxygen that is to the world of the plant. It's called algae. Life is like a beehive. This is the world of breeze. This is the world of breeze. Trees have speciality, control the atmosphere. This series of trees of life. The sun seeds rays take advantage of it, the solar system. Life but alone on the earth. Life but alone on the earth. Trees have speciality, control the atmosphere. This is series of trees of life. The sun seeds rays take advantage of it, the solar system. Life but alone on the earth. Life but alone on the earth. Ultraviolet rays, radiation from X-rays, has the ability to absorb. This tree is not like that. It's the key of life. This life is the characteristic of a tree the only. This life is characteristic of a tree is the only. Ultraviolet rays, radiation from X-rays, has the ability to absorb. This tree is not like that. Is the key to life. This life is characteristic of trees only. This life is characteristic of trees only. Trees have a speciality, control the atmosphere. This is series of trees of life. The sun is set rays take advantage of the solar system. Like but alone on the earth. Life but alone on the earth. Trees have a speciality, control the atmosphere. This series of trees of life. The sun is set rays take advantage of the solar system. Life but alone on the earth. Life but alone on the earth. Can trees withstand the UV and X-rays that come from the sun? Do trees absorb UV radiation? Studies about spectral absorbance, reflectance and transmittance of trees lead to UV radiation. Young et al. 1995 Grant et al. 2003, QI et al. 2010 generally conclude that about 90 to 95% of ultraviolet is absorbed, 5 to 9% reflected, and 0 to 1% transmitted through leaves, regardless of trees species. True plants absorb UV rays. Flavonoids and anthocyanins absorb UV radiation, and they generally accumulate in the epidermis, where they could keep UV radiation from reaching photosynthetic tissues. Heilbrook and Sale, 1989. The epidermis blocks transmittance of 95 to 99% of incoming UV radiation. Robertson and Caldwell, 1978. Is UV light good for trees? Ultraviolet light has been shown to help speed up the process of photosynthesis and lead to increased plant growth. One study published in the peer-reviewed journal Oecologia found that exposure to UVA light increased photosynthesis by 12%. How do plants protect themselves from UV rays? Plants have evolved sunscreen, flavonoids that accumulate under UVB stress to prevent or limit damage. The UVB receptor UV resistance locus 8 UVRI plays a critical role in promoting flavonoid biosynthesis to enhance UVB stress tolerance. 3 November 2021. Does radiation damage trees? There are many endpoints for estimating effects of radiation in exposed trees: suppression of reproductive ability, reduction in fertility of the seed, dried needles, morphological changes, death of trees, and reduction of primary forest productivity can be considered among such endpoints. Can plants survive without UV? What kind of light do plants need to grow? Contrary to popular belief, plants do not need ultraviolet UV light to grow. Plants require blue and red light, which are not a part of the UV color spectrum. Blue light encourages chlorophyll production, which helps the plant create strong and healthy stems and leaves. 30 September 2019. Why don't plants get sunburn? BBC Science Focus magazine. Scientists have known since 2011 that plant cells have a protein called UVRA that can detect shorter wavelength UVB rays, which is the type of UV radiation most responsible for sunburn. This protein signal the cells to begin producing compounds that block further UV damage and repair DNA damage. Trees have speciality control the atmosphere. This series the breeze of life. The sun seeds its rays take advantage of the solar system. Life but alone on the earth. Life but alone on the earth. Trees have speciality control the atmosphere. This series of trees of life. The sun sets its rays take advantage of the solar system. Life but alone on the earth. Life but alone on the earth. Isolated in the ocean, there is the oxygen that is to the world of the plant. It's called the algae. Life is like a bee. This is the world of the breeze. This is the world of the breeze. Isolated in the ocean, there is oxygen that is to the world of the plant. It's called algae. Life is like a beehive. This is the world of breeze. This is the world of breeze. Trees have speciality control the atmosphere. This series of trees of life. The sun seeds its rays take advantage of the solar system. Life but alone on the earth. Life but alone on the earth. Trees have speciality control the atmosphere. This is series of trees of life. The sun sets its rays take advantage of the solar system. Life but alone on the earth. Life but alone on the earth. Ultraviolet rays, radiation from X-rays, has the ability to absorb. This tree is not like that. It's the key of life. This life is the characteristic of a tree is the only. This life is characteristic of a tree is the only. Ultraviolet rays, radiation from X-rays, has the ability to absorb. This tree is not like that. It's the key to life. This life is characteristic of trees only. This life is characteristic of trees only. Trees have a speciality control the atmosphere. This is series of trees of life. The sun sets its rays take advantage of the solar system. Like but alone on the earth. Light but alone on the earth. Trees have a speciality control the atmosphere. This series of trees of life. The sun sets its rays take advantage of the solar system. Light but alone on the earth. Light but alone on the earth. Tree. Friends, the role of trees in the daily life of us humans and animals and birds is amazing. How trees impact our daily life. Besides giving us food, shade and shelter, trees also play a very pertinent role in protecting us from the harmful effects of pollution. More trees would give us pollution-free environment by keeping a check on the increasing levels of such harmful gases as CFCs and carbon dioxide, including other pollutants. The importance of trees, how they benefit our environment and our lives. Plantations International, Growing Your Future, published March 17, 2023. As we go about our daily life, it's easy to take for granted the many benefits that trees provide. Trees are not only beautiful and majestic, but they also play a crucial role in sustaining life on earth. In this article, we will explore the many ways in which trees benefit our environment and our life. The benefits of trees to the environment. Trees produce oxygen. Trees remove carbon dioxide from the atmosphere. Trees help to regulate the climate. Trees prevent soil erosion. Trees provide a habitat for wildlife. The benefits of trees to humans. Trees improve air quality. Trees reduce stress and promote well-being. Trees enhance our quality of life. Trees provide us with food and medicine. Trees contribute to the economy. Trees are a vital component of our environment and our life. They provide us with oxygen, clean air, food, medicine, and a habitat for wildlife. Trees also play a crucial role in regulating the climate, preventing soil erosion, and protecting biodiversity. It is essential that we work to preserve and protect trees and forests for future generations. How trees make a difference? National Wildlife Federation, https www.nwf.organization. Trees for wildlife. About research demonstrates that exposure to trees has a relaxing effect on humans, reducing stress and imparting a sense of well-being. Trees are a beautiful part of the natural environment, but they are also amazingly efficient machines, constantly working to make Earth a healthier planet for humans and wildlife alike. Here are trace 10 proven why that trees make a big difference for communities. Tree being watered by person holding watering can. 1. Trees provide habitat for wildlife. Three main components of wildlife habitat: food, cover, and places. To raise young can all be provided by trees. Wherever trees are established, wildlife and other plants are sure to follow, ensuring a healthier and more biodiverse ecosystem. 2. Trees promote community. Trees can enhance a community's sense of pride and ownership. Active involvement in tree planting programs leads to a stronger sense of community, environmental responsibility, and ethics. 3. Trees cool cities. Trees contribute to urban cooling. Cities develop heat islands because dark roofs and pavement absorb solar energy and radiate it back to the atmosphere. 4. Trees reduce energy cost. Urban tree canopy reduces the urban heat island effect, and this shading from trees reduces energy demand and the need for air conditioning. 5. Trees can boost local economies. The presence of trees in neighborhoods can aid in economic development by increasing property values. 6. Trees improve health. Research demonstrates that exposure to trees has a relaxing effect on humans, reducing stress and imparting a sense of well-being. 7. Trees combat climate change. One tree can sequester or take in more than 1 ton of carbon dioxide in its lifetime. Planting trees and preventing deforestation are key measures in reducing the human impact on global climate change. Learn more about how the National Wildlife Federation is safeguarding our forests and helping wildlife survive a changing climate. 8. Trees increase property values. By enriching the urban environment with aesthetical, ecological, and economic amenities, urban trees increase the value of real estate. Trees 9. Trees clean air and water. Trees remove harmful pollution from the air and forested water state and help clean our drinking water. 10. Trees reduce flooding. Trees lessen the force of storms and reduce the amount of runoff into sewers, streams and rivers, improving water quality and reducing flooding. This is what real love is. A woman with a man. There are mutual relation between the two. Possible the beginning of a new creation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. There are no neutron in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen alone fusion. When to do hydrogen alone fusion. There are no neutrons in the sun's hydrogen, but proton and electron formed as helium and protonated helium. When to do hydrogen atom fusion. When to do hydrogen atom fusion. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. Trees made flowers. Pollinate mutual relations. Fruit form seeds and roots form. Next is I about trees too. Next is I about trees too. Trees made flowers. Pollinate mutual relation. Fruit from seeds and roots from. Next is I about trees too. Next is I about trees too. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new relation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. मंगल ग्रह में से कार्बन डाइऑक्साइड की प्राचुर्यता के कारण बहुत सारा ईंधन इस्तेमाल करके ऑक्सीजन को अलग किया गया था थोड़े से समय के लिए, मगर इस प्रक्रिया के कारण कार्बन डाइऑक्साइड की प्राचुर्यता और भी ज्यादा हो गए थे। लेकिन फिर कार्बन डाइऑक्साइड अवशोषित करके प्रकाश संश्लेषण जरिए ऑक्सीजन को अलग करता है, सिर्फ सूरज की प्रकाश को ही ईंधन बनाकर। पूरा प्रक्रिया को अंजाम देता है। और तो और परिवेश बहुत सुखद पूर्ण बन जाता है। ऐसा कैसे होता है? खैर, कहा जाता है समुद्र में से ही संपूर्ण सतह की 70% ऑक्सीजन हमेशा बनता है, जबकि समंदर में नीले शैवाल को ही ऑक्सीकरण माना जाता है। दोस्तों, बचपन में मैं पढ़ाई जरिए जाना था समुद्री जीवों तथा मछली वगैरह सांस लेता था पानी के ऊपरी हिस्सों में से ऑक्सीजन लेने के बाद। वैसे इसका प्रमाण मैं खुद ऑब्जर्व करके समझा भी हूँ मछली पकड़ते समय। दोस्तों, पता नहीं मैं साइंटिस्ट हूँ कि नहीं, मगर मेरा बचपन को मैं गहरे से जांच किए और आज मैंने समझा मछली हमेशा पानी के ऊपर मुंह ऊंचा कर सांस नहीं लेता है। इसका मतलब है मछलियां पानी के अंदर में ही ऑक्सीजन आसानी से पा जाता है। मगर कैसे? तो क्या समंदर की जीवों ही ऑक्सीजन को बढ़ावा दे रहा है? गहरा समंदर में सामुद्रिक प्राणियां कैसे जीवन धारण करता है? उत्तर, ऐसे वातावरण में गहरे समुद्र में रहने वाले जानवर कई तरीकों से जीवित रहते हैं। सबसे पहले गहरे समुद्र में अंधेरा होता है, क्योंकि सूरज की रोशनी पानी में बहुत दूर तक प्रवेश नहीं कर पाती है। कई जानवर संवाद करने, साथी ढूंढने, शिकारियों को डराने या शिकार को आकर्षित करने के लिए अपनी खुद की रोशनी बनाते हैं, जिसे बायोलुमिनेसेंस कहा जाता है। 1 फरवरी 2008। गहरा समुद्र में सामुद्रिक प्राणियां कैसे सांस लेता है? जलीय जंतु पानी में ऑक्सीजन निकालने के लिए अपने गलफड़ों का उपयोग करते हैं। कुछ जलीय जानवर पानी से ऑक्सीजन निकालने के लिए भी अपनी त्वचा का उपयोग कर सकते हैं। मतलब सिर्फ पैर कार्बन डाइऑक्साइड में से ऑक्सीजन अलग कर सकता है, ऐसा नहीं है। मछलियां भी H2O में से ऑक्सीजन पृथक कर सकता है। मतलब CO2 को जैसे तोड़ने का प्रक्रिया है, H2O को भी तोड़ने का प्रक्रिया है, वो भी बिना प्रकाश की लहरात मिलते हुए भी। साथ साथ ये भी देखा गया, ना तो पानी घटता है, ना ही बर्फ पिघलता है, और ना ही मौसम में कुछ बदलाव बनता है। क्या ये प्रक्रिया काफी है मंगल में बसने के लिए? दोस्तों, आप सोचिए, मैं कुछ और दिमाग में लाने की कोशिश कर रहा हूँ। कुछ तो करना ही है, आखिर बुध, शुक्र, पृथ्वी, मंगल ही जो टेरेस्ट्रियल है। दोस्तों, Mercury, Venus, Earth, Mars, terrestrial movement of life only on Earth. This is called Earth habitable zone under. Only then the biological environment in the Earth. Only then the biological environment in the Earth. Mercury, Venus, Earth, Mars, terrestrial movement of life only on Earth. It is called Earth habitable zone under. Only then the biological environment in the Earth. Only then the biological environment in the Earth. Wonder of the solar system. News of Earth creatures reveal. 9 planets, dwarf planets, how many satellites? There is no epilogue of creatures anywhere. There is no epilogue of creatures anywhere. Wonder of the solar system. News of Earth creatures reveal. 9 planets, dwarf planets, how many satellites. There is no epilogue of creatures anyhow else. There is no epilogue of creatures anyhow else. Mercury, Venus are the more terrestrial. Movement of life only on the earth. It is called earth habitable zone under. Only then the biological environment in the earth. Only then the biological environment in the earth. Mercury, Venus are the more terrestrial. Movement of life only on the earth. It is called earth habitable zone under. Only then the biological environment in the earth. Only then biological environment in the earth. A model of photosynthesis in the earth. Model of behavior of an atmosphere in the earth. We animal exhale carbon dioxide. Oxygen creates photosynthesis. Oxygen creates photosynthesis. A model of photosynthesis in the earth. Model of behavior of an atmosphere in the earth. We animals exhale carbon dioxide. Oxygen creates photosynthesis. Oxygen creates photosynthesis. Mercury, Venus are the more terrestrial. Movement of real life on the earth. It is called earth habitable zone under. Only then the biological environment in the earth. Only then the biological environment in the earth. Mercury, Venus are the more terrestrial. Movement of life only on the earth. It is called earth habitable zone under. Only then the biological environment in the earth. Only then the biological environment in the earth. Apart from Earth, we have not been able to find life in the entire solar system till now. And life survives in the Earth's atmosphere in two ways. One is photosynthesis and the other is convection. Why are photosynthesis and respiration processes necessary in living reality? Relationship between photosynthesis and respiration. All living things, including plants, people, and animals, rely on the cycle of photosynthesis and respiration to survive. Animals and people breathe in oxygen that plants create during the photosynthesis process. Oxygen is then carried by the blood to the cells where it is used for respiration, and carbon dioxide created during the respiration process is released from pupil or other animals and taken up by plants to help them get the energy. The need for growth. This never-ending cycle is what typically keeps life on Earth going. What is the importance of photosynthesis and respiration in plant growth and development? Photosynthesis. Photosynthesis is a process associated with sunlight. In this process, food is synthesized using the component carbon dioxide and water. Using sunlight and the green pigments, chlorophyll, glucose and oxygen are formed as a product. The energy generated is required for growth, flowering, fruit production, ripening of fruit, other metabolic activities of plants, etc. Respiration. The glucose formed during photosynthesis provide energy to the plant. The process of respiration makes effective use of energy. In this process, oxygen is given off by the plants to the surrounding. The carbon dioxide is taken up from the surrounding in used in photosynthesis. The glucose and oxygen synthesized during photosynthesis act as a substrate for cellular respiration in plants. Respiration results in the production of adenosine triphosphate, which acts as the energy currency of the plant cell. Thus, this energy is utilized in the production of photosynthesis, phytohormone, resulting in the synthesis of enzymes, gibberellin, and cytokinin that promote the growth and development of the plant. Hence, both photosynthesis and respiration are important process for plants, and both are interrelated to each other. Which is respiration and photosynthesis important for living things? ORISE, listen, plan, just breathe. An introduction to central focus. Cellular respiration and photosynthesis are biological processes in which matter and energy flow through the biosphere. These two processes are responsible for the exchange of oxygen and carbon dioxide between living organisms and the environment. Mercury, Venus are terrestrial. Movement of life only on a earth. This is called Earth habitable zone under. Only then the biological environment in the earth. Only then the biological environment in the earth. Mercury, Venus are terrestrial. Movement of life only on a earth. It is called Earth habitable zone under. Only then the biological environment in the earth. Only then the biological environment in the earth. Wonder of the solar system. News of Earth creatures reveal. 9 planets, dwarfed planets, how many satellites. There is no epilogue of creatures anywhere. There is no epilogue of creatures anywhere. Wonder of the solar system. News of Earth creatures reveal. 9 planets, dwarf planets, how many satellites. There is no epilogue of creatures anywhere. There is no epilogue of creatures anywhere. Mercury, Venus are terrestrial. Movement of life only on the earth. This is called Earth habitable zone under. Only then the biological environment in the earth. Only then the biological environment in the earth. Mercury, Venus are terrestrial. Movement of life only on the earth. It is called Earth habitable zone under. Only then the biological environment in the earth. Only then biological environment in the earth. A model of photosynthesis in the earth. Model of behavior of an atmosphere in the earth. We animals exhale carbon dioxide. Oxygen creates photosynthesis. Oxygen creates photosynthesis. A model of photosynthesis in the earth. Model of behavior of an atmosphere in the earth. We animals exhale carbon dioxide. Oxygen creates photosynthesis. Oxygen creates photosynthesis. Mercury, Venus, Earth, Mars, terrestrial. Movement of your life only on the earth. It is called Earth habitable zone under. Only then the biological environment in the earth. Only then the biological environment in the earth. Mercury, Venus, Earth, Mars, terrestrial. Movement of a life only on the earth. It is called Earth habitable zone under. Only then the biological environment in the earth. Only then the biological environment in the earth. Mercury, Venus, Earth, Mars is only rocky. Is there no evidence of the remaining 5 planets being terrestrial? Terrestrial planet. Wikipedia, HTTPS, in Wikipedia.organization, Wiki. Terrestrial planet. A terrestrial planet, telluric planet or rocky planet is a planet that is composed primarily of silicate, rock or metal within the solar system. A terrestrial planet, telluric planet or rocky planet is a planet that is composed primarily of silicate, rock or metal within the solar system. The terrestrial planets accepted by the 1AU are the inner planets closest to the Sun. Mercury, Venus, Earth and Mars among astronomers who use the geophysical definition of a planet. 2 or 3 planetary mass satellites, Earth, Moon, Io and sometimes Europa may also be considered terrestrial planets. The large rocky asteroids Pallas and Vesta are sometimes included as well. Albeit rarely, the terms terrestrial planet and telluric planet are derived from Latin words for earth, terra and tellus. As these planets are generally studied by geologists, astronomers and geophysics. Terrestrial planet type exoplanet exploration NASA. NASA.government https exoplanet.nasa.com government. What is an exoplanet? 13 April 2022. Terrestrial planets have a solid planetary surface, making them substantially different from larger gaseous planets which are composed mostly of some combination of hydrogen, helium and water existing in various physical states. What is a terrestrial planet? In our solar system, Earth, Mars, Mercury and Venus are terrestrial or rocky planets. For planets outside our solar system, those between half of Earth's size to twice its radius are considered terrestrial and others may be even smaller. Exoplanets twice the size of Earth and larger may be rocky as well, but those are considered super Earths. Lineup of terrestrial planets. Artists' concept of how rocky, potentially habitable world elsewhere in our galaxy might appear. Data gathered by telescopes in space and on the ground suggests that small rocky planets are common. Placing them so close together in a line is for illustrative purposes only. Credit NASA, JPL, Caltech are hard. Latest news. Discovery alert. Earth-sized planet has a lava hemisphere. Terrestrial planets, Earth-sized and smaller, are rocky worlds composed of rock, silicate, water and or carbon. To determine if some of these worlds have atmosphere, oceans or other signs of habitability, it takes more investigation. Larger terrestrial exoplanets, those at least twice as massive as Earth, are classified as super Earth. How many planets are found by scientists? But do we know how many planets are out there? Astronomers have discovered 5,502 planets around other stars known as exoplanets in the Milky Way. Add in the 8 in our solar system, not 9, Pluto, and that gives us a total of 5,510 known planets, all located in our own galaxy. 8 September 2023. This is what a real love is. A woman with a man. There are mutual relation between the two. Possible the beginning of a new creation. Possibly the beginning of a new creation. This is what a real love is. A woman with a man. There are mutual relation between the two. Possibly the beginnings of a new creation. Possibly the beginning of a new creation. There are no neutron in the sun's hydrogen, but proton and electron formed as helium and protonated helium. Going to do hydrogen alone fusion. Going to do hydrogen alone fusion. There are no neutrons in the sun's hydrogen, but proton and electron formed as helium and protonated helium. Going to do hydrogen atom fusion. Going to do hydrogen alone fusion. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. Trees made flowers, pollinating mutual relations. Fruit from seeds and roots from. Next is I about trees too. Next is I about trees too. Trees made flowers, pollinate mutual relation. Fruit from seeds and roots from. Next is I about trees too. Next is I about trees too. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new relation. Possibly the beginning of a new creation. This is what real love is. A woman with a man. There are mutual relation between the two. Possibly the beginning of a new creation. Possibly the beginning of a new creation. Terrestrial planets Mercury, Venus, Earth, Mars. But terrestrial satellites have also been found to be present in satellites like the Moon and Europa. But one thing is not getting resolved. The Earth is terrestrial and has a variety of living organisms. But there is no presence of any living organism in any of the remaining terrestrial planetary satellites. Why so? Is radiation a big reason? If radiation were a major factor, then we would not want to believe the existence of life on Jupiter, Europa. If radiation were a major factor, then we would not have imagined the existence of life on Mars. Well, it is not that only Earth's life like organisms will exist in the rest of the remains with the prefix terrestrial. Well, friends, till now we have not been able to mark more than half of the life of our Earth. So what happened to the approximately 6 million organisms that have existed so far? Well, the mystery of our Earth's ocean has not been solved yet. When the storm creates havoc, when volcanic terror shows wonders, we never know when an earthquake will destroy us. Life science of our Earth, someone separates carbon dioxide and release oxygen. Many of them remove oxygen from the water while retaining it. Perhaps once the chain of living beings was formed on the earth, it continued to be formed. But perhaps in the rest of the terrestrial planets, life forms did not even begin and a series of life forms did not form. Thanks to NASA. At least NASA is trying hard to settle us in Mars and Moon. Maybe tomorrow we will be the ones who will create a chain of living beings on the terrestrial planets, etc. I am a fan of NASA anyway. If NASA's efforts are successful, then friends, please remember me one. Can life really make its way to an outer planet or satellite? Can life form on other planets, etc., in the solar system or not? You think about it, friends. Till then, allow me to write the next episode of our story, Human Eye.